Hi, and welcome to the second lesson on ENCY Robot Basics. In this video, we're going to be creating a part using the inbuilt CAD system. Once we've got an ENCY open, look to the top left of the screen. Here we have the three workspaces of ENCY: Model, Machining, and Simulation. To create a part, we need to be in the Model workspace, so click there. The toolbar and window pane have now changed, so we should pay some attention to what's happened and why. We're presented with the hierarchy of the model as ENCY understands it. This is broken down into the categories of part, workpiece, fixtures, and restrictions. This gives us a very clear and easy framework in which to construct our projects, and allows us to make changes to individual elements of the project without necessarily having to reprogram the whole thing. We're currently interested in the icons just above the folder structure, specifically the New Design button. This will open up ENCY's CAD system. On the left, you'll have the option to choose which drawing plane you intend to use. Anyone that's used plane-based CAD systems will be very familiar with the workflow. For now, we're going to orbit with the navigation cube a bit until we can easily see the edges of the XY plane. We'll then click on it and click on the sketch icon that shows up. The screen has now changed to a drawing environment, so we'll click on the top pane of the navigation cube just to make sure we're not looking at the plane in any angle other than perpendicular to it. So firstly, we're going to draw a circle. Choose the circle icon on the top bar of the screen, then click the center point of the grid. The mouse should snap to coordinate 0, 0. You can either drag the mouse out to the diameter you want the circle to be, or you can type in the value. I'm going to type in 750 to give us a nice large circle, then press return to confirm the size and shape. Now I'm going to use a single line to define a chord of the circle we've just drawn. To do so, click on the contour button along the top of the window and bring the mouse close to the circumference of the circle. You should be able to see how it's snapping to the circumference. We click once to start the line off, and using the automatically generated construction guideline and the next circumference snap, we've now described a perfect chord of a circle. Once we're happy with the shapes drawn, we click on Back on the upper edge of the left plane. This will take us back to the 3D manipulation workspace. You'll notice that when we hover the mouse over either part of the bisected circle, it highlights that area in yellow. We want to select the smaller area described by the chord of the circle, and then extrude it. However, before we do so, I'm going to adjust the view a bit to show the extrusion size relative to the shape drawn. So I click on the appropriate edge of the navigation cube to shift the view accordingly. That brings us in a bit close, so scroll the mouse wheel up to zoom out, then highlight the smaller chord area and click on Extrude. I'm typing in a value of 1000 here, so you can see how large the extrusion is relative to the sketch drawing. Now that we've defined our shape, we can click on Back again to leave the part modelling space. This has put us back into the model space, and we can now see our part relative to the robot in the turntable. As you can see, the orientation, scale and placement of the shape aren't exactly right for machining. To remedy this, we're going to use the transformation tools. With the shape highlighted, we click on the transform icon at the top. Firstly, we want to rotate the shape to lie flat on the turntable. A quick note to assist with this: if you're not sure of the orientation that the object needs to be rotated in, compare the colours on the axial indicator on the turntable to the colours on the navigation cube. Here we can see that it needs to be turned in X. We also get a preview of the new orientation before committing to it, so we can see that it doesn't want to be turned minus 90 degrees but rather plus 90 degrees in X. I now want to rescale the piece a bit, since it's rather large and doesn't fit on the turntable. In the scaling window, we have the option to adjust the scale in each axis, and overall. I'm going to rescale the entire shape, so I type 0.5 into the overall text box and apply. Finally, we want to position the piece. We have a couple of methods that can be used here. I'm going to locate 0 first, using middle for the X and Y axes and min for the Z axes, then clicking apply. Alternately, you could use the move and the coordinate commands involved. However, we're going to go to the move tab and just lift the part up in Z by 150mm to make sure that there's no contact with the turntable. At this point, we have the option of being able to define the CS, or coordinate system to use. The default options are typically defined from the base and center point of the robot itself, and the center point of the turntable's top plate. For the sake of repeatable jobs, or specific orientations for parts of a job, defining a specific CS may well prove necessary. It's much like defining G55, G56 and similar locations in CNC work. More often than not, it's perfectly fine to work using an offset from G54, but there are always jobs out there that need to have their own dates and points defined as well. Since this is a single piece job that's based entirely on the available motion from the turntable, we'll use the turntable CS definition. However, say you're aware of how to set CS for the future, it can be done from here by entering X, Y and Z coordinates directly. This concludes the second lesson in ENCY. In the next video, we'll be covering operation setup and toolpath generation.